fifth graders, today we're going to look at a strategy for multiplying fractions called simplify before you multiply. And just a recap of what you learned before. When multiplying 2/4 times 5/10, you learned that you can multiply your numerators, multiply your denominators. So 2 times 5, 10, 4 times 10, 40, and then make sure your answer's in simplest form. So 10/40, that is not simplest form. So we have to think about what is the largest number that will divide into both 10 and 40. And the largest number that will divide into both 10 and 40 is 10. So 10/40 wouldn't be the simplest form. I would have to divide both my numerator and denominator by 10 to get 1/4. So the answer to 2/4 times 5/10 is 1/4. Okay, now what I want to show you is our little strategy on simplify before you multiply. What we could have done is we could have simplified our fractions before we multiplied, meaning this. I have 2/4 and 5/10, right? Well, when you look at 2/4, that's not in simplest form. 2 goes into both of those. 2 goes into 2 one time. I'm going to rewrite this down here. 2 goes into 2 one time. 2 goes into 4 two times. So really, the 2/4 I could write as 1/2. Now when you look at the 5/10, that's not in simplest form. 5 goes into both of those. 5 goes into 5 once, and 5 goes into 10 twice. So by simplifying those fractions beforehand, you can actually end up arriving at the same answer. We're left with 1 times 1, which is 1, and 2 times 2, which is 4. And we can see that 1/4 equals 1/4. And you might think to yourself, well, why can't I just simplify the 10/40? That's fine. I'm going to show you another example of why you would want to know this nice little shortcut, okay? The next problem is 3/10 times 5/12. Now, if you solved this out the regular way, okay, we multiply our numerators, right? We do 3 times 5, and 3 times 5 is 15. And then multiply your denominators. 10 times 12. That's 120. Now we're left having to simplify 15 over 120. It's a lot easier to simplify lower digits than it is higher digits. So that's where this little shortcut is helpful, okay? But you might be thinking to yourself, 3/10, I can't simplify that. That's already in simplest form. And 5/12, well, I can't simplify that. That's already in simplest form. But here's the thing. We learned about a lovely little property called the Commutative Property that says that the order that we multiply numbers doesn't matter, meaning that 3 times 5 is 15, but 5 times 3 is also 15. So what if I did that? What if I said 5 times 3 instead, and then kept my 10 times 12? Well, now when we look at this, I'm going to switch markers. That one's not coming out as nice as I would like. Now I see 5/10. We just simplified that, didn't we? 5 goes into 5 once, 5 goes into 10 twice, and I have 3/12. 3 goes into 3 once, 3 goes into 12 4 times. So what's left here is 1 times 1, which is 1, and 2 times 4, which is 8. So 15 over 120 is what you would start with. 1/8 is the simplest form. So by simplifying before you multiply, you can jump right to that instead of having to try to simplify 15 over 120. So let's take a look at this next one. I have 3/8 times 2/15. 3/8 times 2/15. So this means 3 times 2 to get my numerator, and 8 times 15 to get my denominator. Okay, now, in looking at this, I want to see, can I simplify beforehand? Now, I know I can't simplify 3/8, and I know I can't simplify 2/15, but I do know that I can change the order of my factors with multiplication. So what I'm going to do is I'm going to switch around the 8 and the 15 and change it to 15 times 8 instead. I'm allowed to do that. I'm going to get the same exact answer in the end. Now I'm going to simplify beforehand. So see 3/15ths? The largest number that divides into 3 and 15 is 3. 3 goes into 3 one time. 3 goes into 15 5 times. So instead of 3/15ths, we're dealing with 1/5. Now look at your 2/8. The largest number that divides into 2 and 8 is 2. 2 goes into 2 once. 2 goes into 8 4 times. So instead of using 2/8, we can use 1/4. Now, when I multiply across the top, I'm going to use my simplest form. I'm left with 1 times 1, which is 1, and 5 times 4, which is 20. 1/20th is in simplest form. I don't know about you, but I think that's a lot nicer than having to do 8 times 15 and having 6 over that and then trying to simplify that. So being able to simplify beforehand is quite helpful. Okay, let's look at letter D. Letter D is 8/49 times 7/10. Now at this point, if a parent or guardian is watching you do this, they might think, well, I didn't rewrite it like that. This is what I did. And I'm going to show you, because this is kind of the shortcut way to write it. If you don't like the shortcut way to write it, then don't write it that way. Write it the other way and move your factors around. But what you can actually do is called cross simplify, because I can switch the order anyways. So when you see 8/49 times 7/10, before multiplying across the top and multiplying across the bottom, I should see if I can simplify this, because it makes it a lot easier. I know I can't simplify 8/49 if it was 7/49, but it's not. And I know I can't simplify 7/10, right? But we said we can switch the order around. We're allowed to. So what actually could happen is I could move this 10 over here and the 49 over here. This is where we call it cross simplifying. Cross meaning across from one another. Those of you that played bingo with us yesterday, diagonals. Okay, so I'm going to look at 8 and 10, because I know I could have that 10 underneath it instead. And the largest number that goes into 8 and 10 is 2. 8 divided by 2 is 4, and 10 divided by 2 is 5. That's called cross simplify, because we just simplified the digits that were across, or diagonal from one another. Now you see a 7 and a 49 diagonal from one another. We can simplify those as well, because I could have moved the 49 there. It's commutative. So between 7 and 49, 7 goes into both of those. 7 is the largest digit. 7 goes into 7 once, and 7 goes into 49 7 times. So now I can multiply 4/7 and 1/5 instead. And I use my same method as before. I multiply my numerators. 4 times 1 is 4, and 7 times 5 is 35. And there's not a number that goes into 4 and 35 other than 1. So we know that this is in simplest form. So this cross simplifying process, it would have worked for the other ones too. I'm going to show you. I'll kind of bump this up and we'll just take a quick trip to the problems that we just did. So for letter C, I rewrote these. But originally, what I could have said, okay, well, 3 is diagonal from 15. So I can cross simplify those. So I'm looking at the 3 and the 15 because they are diagonal from one another. 3 goes into 3 once. 3 goes into 15 5 times. Now looking at the 8 and the 2, which are diagonal from one another. 2 is the largest digit that goes into both of those. 2 goes into 2 once. 2 goes into 8 4 times. So you see, we'll get the same answer here. We got an answer of 1/20th before. 1 times 1, after we simplify is what's left, is 1. And 4 times 5 is 20. We could have done that with letter B as well. With the 3/10 times the 5/12. If I wanted to cross simplify this, because I see, I can't simplify either of those, but 3 and 12, 3 goes into both of those. 3 goes into 3 once. 3 goes into 12 4 times. 5 and 10, I can cross simplify those. 5 goes into 5 once. 5 goes into 10 twice. So if we did it this way, we can see 1 times 1 is 1. 2 times 4 is 8. 1/8. That's exactly what we got. So whether you want to rewrite it out like this and switch your factors around, that's fine. Or if you just want to go ahead and cross simplify, that is fine. Okay, a couple of examples I want to make sure you see is what do you do when there's a whole number? Well, think about what we did when there was a whole number last time. We said we wanted to multiply fractions. We needed fractions, right? 2/3 is a fraction. 2/3 is already in simplest form. 15 isn't a fraction. To make 15 a fraction, all I have to do is put a 1 underneath it. Now it's a fraction. 15 over 1 has the same value as 15. Okay, 2/3 I can't simplify. 15 over 1 I know is 15. So I can't simplify either separately, but let's look at crosswise. 2 and 1. There's nothing I can do. 1 is the largest number that divides into both of those. But 3 and 15, there is something I can do. 3 divides into both of those. 3 goes into 3 once. 3 goes into 15 5 times. So now all I have to do is multiply across the top. 2 times 5 is 10. 1 times 1 is 1. And 10 over 1 isn't simplest form, that's improper. So just ask yourself, okay, what is 10 divided by 1? Because that's what this means. And 10 divided by 1 is 10. So the simplest form answer there would be 10. And if you think about it, if you have 2 out of 3 15 times, you would have 10 whole. All right, last but not least, if we're multiplying fractions, I need to make sure these are both fractions. So I'm going to put a 1 underneath that 12. Now, I look at 3/4. I can't do anything to that. I can't do anything to 12 over 1. So now I'm going to check my diagonals. 3 and 1, nothing I can do. 1 is the largest number that divides into each, and that's not going to change it. But when you see 4 and 12, 4 divides into both of those. 4 goes into 4 once, 4 goes into 12 3 times. Now we're ready. We multiply across the top. 3 times 3 is 9. And across the bottom, 1 times 1 is 1. And 9 over 1 is improper, and we can't have that. 9 divided by 1 is 9. And you are done. Good job. Thanks for listening.